are the midpoints of sides. Okay, let me here triangle A, B and C. D is the NP of BC. Okay, D. Similarly, E is the midpoint A and similarly F is the of AB. Hope this is clear. Since if we join up all this, now he is asking us to remove the areas of the ratio of the areas of triangle DEF, that is your inside triangle, and the outside triangle ratio, right? Good. So let us see how we can remove the ratio of this one in triangle. If you're looking at triangle in triangle ABC, that EF is what is the line joining of midpoint of two sides, that is AB and AC, isn't it? Similarly, so that I can say that FE is parallel to BC, isn't it? How can I say that? By using the basic proportionality theorem, I can write this as EF by FB is equivalent to by EC, isn't it? You are dividing it out, right? Similarly, I can write what I can write here is DE, whatever the DE line is divides AC also and also BC in same ratio, in this same ratio, so that I can write that DE is parallel to AB, isn't it? Now, if you look at this part here, what is that? If in the quadrilateral B, D, E, and F, both pairs of opposite, I can say that both pairs of opposite sides. So, what are these sides? These sides are BD, what parallel to F, and also DE, if you look at the diagram, is parallel to F. These are what? These both are parallel, isn't it? Yes. So I can say that now, as they are parallel, I can say that the quadrilateral DEF is a parallelogram, right? If it is a parallelogram, and you can say that DEF is a diagonal. Okay, diagonal. Hope this is clear to everyone. That is B and F. I'm speaking about this region. Okay, I'm speaking about this region. Now I can say the similarity, that is triangle DEF approximately equivalent to triangle DEMF, right? So let me write equation number 1. Similarly, I can also write that triangle DEF is equivalent to triangle and D, isn't it? So this is your equation number 2. And also I can directly write that DEF is approximately equal to triangle EAE and E, right? How can I do that? Because as you have seen earlier, I know that EAEF and your D is a parallelogram. Okay, it's a parallelogram, right? So what I'll do is I need to add up all this, right, from 1, 2, and 3, from 1, 2, 3. If I look at this, all these are from triangle. That is, I can say that what I can say that I can the triangle ADF is equal to triangle DEF, and this is again approximately equals to triangle. And also can also say that what I can also say that this is also equivalent to your triangle for TF, right? So this is clear, and these all are from what? These all are from triangle, that is ABC triangle can be written as triangle F plus triangle DEF plus Also, I can write the same thing for the other triangle. That is yes, and the triangle what B, D, and what F. Right. So this is isn't this all equivalent to 4 times of triangle D, E, and F, right? So at last we require the ratio of triangle ABC is equivalent to the ratio of triangle DEF. That is how much. So this is clear to everyone, right? So let's look at the next one. So this is your sum number 2. Let's see your sum. Okay. Okay, in triangle ABC, first of all, draw a triangle. CN. Now XY is what parallel to AC. For AC, I should draw a line segment. The parallelity rule. Okay. Now, next thing, and XY divides the triangle in two parts of equal area. Okay, you remember that it's of equal area. Find the ratio of AX to XB. Okay. Now let's see how we'll do this, right? So if you're looking in the diagram here, I can say that what I can say that in ABC and also in triangle XY. Can I write this angle in this, right? And eventual angle A is X and eventually angle equal angle y. How can I write this one? Because see, how can I write this? I can write all this because since xy is what parallel to AC, okay, and the other angles, that is angle E comma angle X and angle C comma angle Y are corresponding angles. Corresponding angles are always what? So that's why. So from this, I can say that triangle A is approximately equal to triangle X, B, and Y by using angle similarity condition. You have the criterions. Remember, so by using that criterion, I can say that similarity condition. Okay. I can say that these are equal, right? Good. Hence, I can write this triangle by triangle xby can also be written as ab square by x b square because the ratios of similar angles are equal to squares of their corresponding sides, right? So this is can be written as by 1 and ab square by xb square. How did I write this? Because this is given, right? Given triangle ABXY is equivalent to triangle BXY is equivalent to triangle BA, right? So therefore, I can say that what triangle A equals to triangle for X, B, and Y. Okay. So by solving this one, how do we solve this? We need to solve this one out, right? So let me use a combined dividend here. So by 1 is equals to AX. I can write AB as like this, isn't it? On the diagram, right? And similarly, XB. Now the whole square is taken to right over here, whole square. Okay. So now let me divide this one separately so that I can find that AX by plus XB by XB. Okay. So this is clear. So this is also whole square, whole square. Now this is out. So this is written as 2 is equivalent to x plus xb plus 1 to the whole plus 1 to the whole square, right? Now shifting the square to the other side so that I'll get root 2 is equals to ax by xb plus 1. Now shifting to the other side, the number I will get something like that clear to everyone. Hence, this is your required ratio. This is your required ratio. Hope this is clear, right? So let's look at it. Prove that the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding medians. Okay. So let me draw two similar triangles. Now let me have a so this is one triangle, and this is your other triangle except y and z. As he has said here, the medians are your latitude, right? This is your attitude and this is your attitude. Let me name it over D here and let me name it some W here, right? So this is 90 degrees and this is also 90 degrees. Hope this is clear, right? So given, so let us write the given content first. The given content is triangle A equivalent to triangle XYZ. Okay, now what is asking? He's asking us to show that the triangles ratio, triangle ABC divided by triangle XYZ, this ratio is equivalent to the attitude height, right? So that is the attitude means the median side. Okay, so let us do the proof here. So let us solve this here. Here we know that the ratio of areas of two similar triangles is equal to the ratio of the squares of that one. What I mean to say is, we know that triangle ABC divided by triangle XY and Z is equal to AB square by XY square. So let me name it as equation number 1. How can I write this? I can write this because we have assumed that the triangle XYZ is ABC is equal to triangle XYZ. Right, good. So now in this triangle, now what can I write is in triangle ABD, and also if you observe in triangle Y and W, I can observe that angle B is equal to angle Y and also angle D is also equivalent to angle W. That is how much? That is 90 degrees from the diagram, right? See, this is using your angle criteria, right? Similarity. By using this similarity, I can write this one, right? Simply with similarly, so this is equation number 1. So similarly, what can I take? Let me assume the other side triangle, that is triangle ABD is approximately is equal to triangle XYZ is, as we have observed here. So that I can write here, what I can write triangle ABC by BC by triangle XYZ is equals to AB square by XY square, as in the first equation. This is also equivalent to AD square by XW square. This is your equation number. Okay. So that from 1 and 2, what can be deducted? I can directly write triangle AB, area of triangle AB, that is squared by area of triangle XYZ is equivalent to your altitude, that is their altitude, right? This is your two required to prove, right? So this whatever is written over here in the division is your statement, but you can write it this one directly up to here, right? So wherever I have underlined now, you can write that one out directly, right? So let's look at the next one. So this is your question 4 sub 6. Yeah, read the question and name. Here is approximately equal to your triangle D by triangle D. What here? Triangle D and F1. Okay. Now BC is how much? 3 centimeters, 3 centimeters, and EF is how much? 4 centimeters. EF is 4 centimeters, and similarly the area of the triangle is how much? 4 centimeters. Right? Now he is asking us to determine the area of the other side of the right angle. Okay. So as he has given here already that triangle ABC is equals to triangle what? D and F, right? So what can be written? Triangle ABC divided by triangle F is equals to BC square by F square. Right? This is what this is the earlier we have done this, right? The ratio. Let me write here. Ratio of two similar triangles. Right? It's your similar triangles is equal, which is always equal to the ratio of the squares. This is always equal to the ratio of the squares of the two of the corresponding, not two corresponding sides. Hope this is clear, right? So let me solve this one. What is the area given? for now, this is the area we need to remove. DEF is equals to B square is what one thing given, the other square is your 4 square, right? Now cross multiplying this one for here and this one for here, I have left off with what triangle DEF can be written as 4 square is 16 into 54 by this comes out to be 9. Hope this is clear. Hope this is clear to everyone, right? So how do we solve this? If you're solving this comes out as x values using your 9 table. This comes time. So if you're doing for the answer 96 centimeter square. Hope this is clear. Hope this is clear. So this is the area which you're required to remove. Let's look at the next one. For a triangle, we are having a triangle ABC. So that AQ is a straight line meeting AB in P. Okay. AC in Q means you have some line here that is like this. P and what? Q. If AP is 1 centimeter, if and BP AQ is 5 centimeters and CQ is 4.5 centimeters. Now into that area of the triangle is 1 by section of this one. Okay. Okay, let's see how we will do this one here. If you look at the first one, let me take the ratio AP by PQ. The ratio comes out to be 1 by 3, right? So this is the equation. Finally, let me take the other ratio AQ by QC. So 1.5 by 4, right? That is, if I divide this, I'll get what? So let this equation number 2 here, right? So from 1 and 2, from what 1 and 2, what can be deducted AP by P is equivalent to AQ by QC. Hope this is clear, right? Hence, from this deduction, okay. So by using basic proportionality theorem, I can say that PQ is what parallel to BC. Okay, parallel to BC. Now in triangle AP and Q, and in triangle ABC, angle A is equal in these two triangles, right? Isn't it? And angle P is equal to angle. These are your corresponding angles for the parallel lines, right? These are the corresponding angles for your parallel lines, right? So from this, I can say that triangle AP is approximately equals to your triangle AB. See, how can I say this? I can say this using angle criterion parity, right? Now, so as we all know that it is equated out, so let's see how we will solve this one, right? As we have the theorem that the area of one triangle and the area of the triangle, that is the ratio of the two triangles, the square of their attitude. So clear, in the earlier sum we have done this, right? We have proved this. So substituting the values here, 1 square by 3 plus 1 to the whole square, right? So this is equivalent to, right? This is what 1 by 16. So now therefore I'm just shifting this AP by triangle ABC is equals to what 1 by 16 cross multiplying this here, cross multiplying these two, what we triangle APQ is equivalent to 1 by 16 times of triangle. This is what required to prove, right? And proved. Let's look at the next question. This is your sixth this exercise, right? So this is let us see how we'll do this. The areas of two similar triangles are this one. So let me draw two similar triangles first of all, so that they don't feel them. And I'm naming this as what this is A, this is D, this is E, but F. Okay. With their attitudes, because you're having right some so and let me X over here, right? If the attitudes of the bigger triangle is 4.5, okay. The attitude of the bigger triangle is given as how much? 4.5. Find the corresponding attitude of the smaller triangle. Passing smaller triangle H0, right? So let me write the given data first, so that there won't be any clarity. So for we put the triangle H to triangle D, E, and F, and also area of the triangle ABC is given as 80 square, and also the area of the other line is given as 49 square. Now AX length is also given as same, right? Now if you have seen in the earlier sums, we know that the area of triangle A by triangle DE and F is equivalent to AX square by dy square. Hope this is clear to everyone. Right now I'm just substituting the values in one, just picking up the values and directly substituting in formula above so that I will get the dy square. Now dy square can be asked to right into what in 40 by right by 81. If you're solving the square of 45 is 2025, so that's one unity. You can drop it like this. Now I'm shifting the square to the other side so that I can write 4.5 whole square as it is and go to square and this times square. When I'm writing the root and all the squares inside has been. So now dy is left out 4.5 into 7 by what 9. Doing these two into and dividing the result plus 3 as your answer. As hope this is also clear to everyone.